my iPad screen. Let me know that as well. If it just happens to go black for some reason, that's happened occasionally. If it ever quits updating, let me know that as well. I mean, I think everybody's been before, but if I'm ever talking about doing work or talking about math in any way, I will be writing on the screen. And so if I've been talking about work for 5 or 10 seconds and you're not actually seeing that work, then that probably means the screen is frozen. If that happens for you, just let me know. Okay, all right, cool. So I appreciate your survey responses. We'll get going. Normally we plan for about an hour. It will not take the full hour only because there's this week's topics in 172 are to a large degree continuation of last week's topics. Last week we looked at vectors and the law of signs, or you looked at vectors and law of signs actually in your class. We talked about the prereq skills for both of those. Vectors is a topic on test 2, the vectors ideas from last week. The law of signs will not be a test 2 topic. It's covered on test 3. For this week, we're going to talk about the law of cosines and then applications for the law of sines and law of cosines. So what we're going to start off with is, I'm just going to mention the law of cosines. We don't actually have any we don't really have any prereq skills that we can talk about for the law of cosines. I'm going to draw it up here. I'll just mention what the law of cosines is and when you might use it. And I'll write down the various equations for the law of cosines, and then we'll actually spend the majority of our time talking about the law of sines and some application questions, because a big portion of your material for the week will cover applications. So the law of cosines looks a whole lot like Pythagorean theorem. We would use the law of cosines to find a missing side length of a triangle when the law of sines maybe doesn't work. So a squared equals b squared plus c squared minus 2bc cosine of angle A. That's one version of the law of cosines. There's 2 other versions. They each start with b squared and c squared. So if we're looking to find out side b, the equation would be that b squared equals a squared plus c squared minus 2ac cosine of angle B. And then if we want to find side C, the equation is a squared plus b squared. Start with that. Minus 2ab cosine angle C. So when I mentioned at the beginning, it looks a whole lot like Pythagorean theorem. What I was talking about is the first 3 terms in each of these equations, the minus 2 whatever cosine of an angle. That's kind of an amendment to Pythagorean theorem, but all of these start out pretty similar to Pythagorean theorem. So just to I'll point out a couple of things. If we're using the equation to figure out side A, we're going to have angle A inside of the trig function. If we're finding side B, then we'll have angle B in the trig function. And if we're finding side C, then we'll have angle C in the trig function. That's maybe some helpful ways, or maybe some portion of something I've said in the last minute or two will be helpful for keeping these straight. You'll need to have these memorized. The equations won't be provided on the test. But this is the law of cosine, just like the law of sines. It's just an equation that we use to find whatever missing stuff we're interested in from a triangle. And remember, just in general, solving triangles means to find all the missing sides and all the missing angle measures. Questions about anything I said? Not a whole lot of instruction. Okay, so what we will do, and this is about as much prereq stuff as we actually can cover at the moment for the law of cosines. So if you're looking for, I'm going to take all those squiggly lines away. If you're trying to figure out side A, then we can, you're trying to figure out side A, we can take the square root of both sides of this equation, right? The equation in black is the law of cosines equation. But if we take the square root of both sides, that will actually give us the value for side B, or for side A. Same thing is true for the second equation. If we square root both sides, that gives us an equation for B. And then, of course, for the third equation, the same thing is true down there as well. If we square root both sides of the equation, we can solve that for C to give that C is equal to the square root of A squared plus B squared minus 2AB cosine C. So again, what I wrote originally in blank, those are the three versions of the law of cosines equation. But really your point will be to solve either for side A or side B or side C, and that's what's happening over here off to the side in red, blue, and pink. So those would probably be the colored equations, would probably be the ones that would be the most valuable, I guess, if you're trying to find a side length. Let's make a note of that. Oh, not like that. So let's say that instead of trying to find a missing side length, we're trying to find a missing angle. What I'm going to do is take the very first equation there, a squared equals b squared plus c squared minus 2bc cosine A. What if we solve this equation for A? Which will, not can, but will legitimately be one of the things you're asked to do this week. You can also use the law of cosines to determine a missing angle measure. In the first version of the equation, the only angle measure we can solve for is angle A. In order to solve for angle A, what we would do first is subtract b squared and c squared from both sides. So that tells us that a squared minus b squared minus c squared equals negative 2bc cosine A. Again, just keep in mind we're trying to solve for angle A. So what I'll do next is to divide both sides by negative 2bc. That tells us that the cosine of angle A is equal to a squared minus b squared minus c squared over negative 2bc. And then to get angle A by itself, last thing is to remove the cosine function by using the inverse cosine function. And that tells us that angle A is equal to inverse cosine of a squared minus b squared minus c squared over negative 2bc. Put a red box around it to indicate that the equation that's written there is the equation that would be used to determine angle A. But literally what we're doing is taking the original equation from way back up there, moving everything to the other side, and isolating the capital A, angle A, by itself. Questions about how we did that, or why we would do that, or how anything worked? The majority of that, we only used trig. The first time we ever used anything from our trig class was right here when we took the inverse cosine, but every other thing we did is a prereq skill of some sort from some other time in life. Okay, so I'm going to scoot that up, and let's try, let's do the second equation there, b squared equals a squared plus c squared minus 2ac cosine b. I'm going to give you a minute or two or however many to try solving this equation for b, for angle b. And again, which will legitimately be part of your work for the week. So essentially what we're doing is solving these equations ahead of time so that when it's time, maybe it's simple enough to just use the rearranged version we've got there in the red box. If we need angle A, you can use the version in the red box. If we need side A or side B or side C, you can use the square root equations we've got it a little higher up in the various colors there. So what we can do is subtract a squared and c squared first. Whoops. So b squared minus a squared minus c squared equals negative 2ac cosine b. Next, we'll divide both sides by negative 2ac. So that cosine of b is b squared minus a squared minus c squared over negative 2ac. And then that means that b, if we use the inverse cosine at this point, that tells us that b is equal to inverse cosine of b squared minus a squared minus c squared over negative 2ac. So again, if your task at some point when you're answering questions for the week is to solve for angle B, you can use, of course, for every one of these, you can always start with the original version of the equation, but maybe having the rearranged version like what we've got here in blue, if that's helpful, of course, you can just kind of start off with that from the beginning. Questions there? So just to wrap all this up so that we have technically all six of the rearranged versions we might need. If we're after angle C, we would start with the c squared equation. So that c squared equals a squared plus b squared minus 2ab cosine c. And rearranging that, solving it for angle C, we're going to get that angle C is the inverse cosine of c squared minus a squared minus b squared over negative 2ab. You don't necessarily have to spend the time to solve that one. It works out the same way the earlier two did. But the three equations we have here in the colored boxes, red, blue, and then pink, those are the equations you would use to find missing angles, either angle B or either angle A or angle B or angle C. And the ones we wrote up here, no boxes around them, but the colored versions of the equations would tell us either side A or side B or side C. But every one of them came from the original equations we had here. The original equations didn't have the square root symbols in them. But that's the law of cosines. Again, there's not a whole lot we can really talk about it. Just that is the law of cosines, and you'll spend your time this week using the law of cosines to find missing side lengths of triangles or missing angles in triangles, but also in solving applications, which our focus for the rest of our time will be applications, and then we can answer questions like always. Maybe, if you're getting ready for the test or something like that, we can do a kind of a review or something. So what I'm going to do, questions about anything we did there? Okay, what I'm going to do is put one question in the chat. Eventually we'll look at 3. This first one, if you were here last week, looks familiar, should look familiar. It was one of the questions we looked at last week. We didn't actually answer it. We set it up, but we didn't answer it. Our point for this week, again, since we're going to review setting up diagrams to solve problems. So what I'm going to do, since we did already look over this one together, I'm going to give you a chance to draw the diagram for this one from last week to see how much of what we covered you remember with the angles and the directions and such. For the question in the chat, I'll wait a minute or two and then we'll chat about it, but we'll actually answer it this week while we review the law of sines to do that. So just to review real quick, we have the headings given for the direction that the directions these roads are traveling. So 71 degrees north of east. Remember what that means. It means that we start in the east direction and we're going to turn 71 degrees towards the north. So when we're down here drawing the path this car's traveling, at one point they had the option to exit 71 degrees north of east. If they miss that exit, they travel an additional 12 miles and then need to exit 34 degrees west of north. What that means is starting in the north direction, turn 34 degrees towards the west. So that second road would be here, but the angle we're given is out here, 34 degrees. So just thinking back to last week, either your material from 172 or your material from when we were together, the 34 degrees, it's not the angle we need. To find missing side lengths, we need the angles inside of the triangle. So we can find, I'll put it down here in red since it's not original information, but to find the red angle, we can use 90 minus 34 to get 56. The task, the question is to figure out, I'm just going to label them as side A and side B, but the task is to figure out the distance from the main road to the cafe. And how we would do that, or how we do that, is by finding the measures of the two sides, the left side and the right side.
How did you get?
How did I get what?
56.
Hope if I subtracted right, it's 90 minus 34.
Oh.
Because these two together make a 90-degree angle. They make quadrant 2. So they should add to 90. Yeah, 56. So, since you covered the law of sines last week, we can actually solve this, and we will, because it'll be a good review of that. But to find side A, we would use the sine of 56 degrees over its side length equals, and what we have to have anytime we're completing the law of sines, we have to use a complete angle side pair. So what I mean by that is angle B and side B are a pair. Angle A and side A are a pair. Angle C and side C are a pair. So in order to use the law of sines, we have to know both an angle and the side opposite from it. We do know that here. It's not actually labeled, but we do know it and we can find it. We can get this missing angle measure at the top here by subtracting the original two, 71 and 56, from 180. So that top angle is 53 degrees. So using the law of sines, we can now finish what we started, I guess. Sine of 56 over A equals the sine of 53 over 12. So we have this proportion. We practiced solving proportions just like this last Monday. You solved proportions like this throughout the week last week as well. And we will solve it. Before we do that, any thoughts on the value of side A over there? Just any general thoughts about the size it should be? Is 10 miles reasonable? Is 13 miles reasonable? Is 25 miles reasonable? Any thoughts on that? Because having some sort of kind of idea in mind might be helpful. And we can get an idea.
It should be a little bigger, right?
Yeah. So anytime you're working with these triangles, larger angles will create larger sides. The opposite of that, smaller angles will create smaller sides. That's true as well. But looking at the 53-degree angle and its pair, its partner of sorts, the 12-mile side, 53 is pretty close to 56, right? It's not a big difference. So when we're finding the value of side A, I don't expect it to be a whole lot. It should be bigger than 12, right? Its angle is bigger than 53, so the side should be bigger than 12. But I don't expect it to be dramatically bigger. I'm not expecting it to be 30 miles. Will it be 13? Will it be 14? Maybe, I don't know. I'm not entirely sure about that. I don't really have a huge insight there. But I am expecting it to be pretty close to 12. So just kind of keeping that in mind, we can assess, our answer at the end when we get it. Cross multiplying now, we get 12 sine 56 of, equals a sine 53. And to solve for a, we'll divide both sides by sine 53. Which tells us that a is equal to 12 sine 56 over sine 53. I'll reiterate or emphasize what I said last week. Using the calculator as few times as possible is the best idea for these. So we will only use it a single time here, and I'll put in exactly what we've got. 12 sine 56 divided by the sine of 53, which tells us that our missing side, angle A, or side A, is approximately 12.46 miles. So, that's probably in line with what we assessed at the beginning. It should be close to 12. It shouldn't be astronomically bigger. Certainly shouldn't be smaller at all. Yes, Sarah, you will have calculators on test 3. You'll be allowed to have them on test 3. Yeah. Questions about anything we did to get side A there? If not, I'll give you a minute or two to figure out side B to see how far the cafe is from the other exit. Let's see. I'll leave this here in case you want to look at it, but in a second I'll scoot it over to do the work for side B. Perfect. So the law of signs for side B is really similar to the law of signs for side A. What we'll do is create our proportion sine 53 degrees over 12. Since we're after B now, we'll need to use the sine of 71 degrees over B. But solving it's literally always the same. 12 sine 71 equals B sine 53. Dividing by the sine of 53. We get that B is equal to 12 sine 71 over sine 53. Before we put this in, and maybe you've already put it in my questions too late, what do we expect for the value of side B? If you've already done it, that's totally fine too. But since 71 degrees is the largest angle inside the triangle, B has to be the biggest side of the triangle too. So B is going to be at least 12.46 miles, because currently that's the smallest value we've got, and B has to be bigger than that. Really, 71 degrees is a fair bit bigger than 56, so I'm expecting that side B is going to be a fair bit bigger than 12 and a half. Is it going to be 15 or 16 miles? I really don't have any idea of that, but I'm not expecting it to be 12.46, and I'm not expecting it to be all that close to 12.46. So let's see, 12 sine 71 divided by sine 53, 14.21 miles. And, like I said, that is a fair bit bigger. That's a really generic way for me to describe it, but it shouldn't be really, really close. I don't have any concept of how much bigger it should be. That varies from, that there's a whole lot of factors that go into that. But if you're comparing a 53-degree angle to a 54-degree angle, the side lengths opposite of them should be really similar. If you're comparing a 70-degree angle to a 50-degree angle, it shouldn't be terribly similar. I don't mean it has to be double in size, but it should still be a fair bit bigger anyway. But having that kind of concept in mind when you're working through these will be really helpful for assessing your answer at the very end. It might be a really great way to find out or to spot that maybe you have made a mistake of some sort. Let's see, I can probably fit that. Questions about anything we said or did there? So just thinking back or going back to what we said last week, we had two different ways to describe directions of things. This is one of the ways, right? 20 degrees north of west, 70 degrees south of east, whatever it was, but actually phrasing it in this exact order was one of the ways we encountered last week. We will look at, we're going to go back to another one of the questions we did last week, the one where the folks were throwing the football at the beach. We set it up last week, so hopefully some portion of it is, maybe still familiar, at least the directions and headings that are in there. So just to remind you of what these directions mean, south 42 degrees east means starting from the south direction, turn 42 degrees towards the east. So that would be the line we would draw based on this particular bearing here. So I'm going to do just like the one we've just wrapped up. I'm going to pause here and give you a minute or two to draw this diagram. Again, if you haven't thought about it in a week, or since last week, it would probably be just as helpful to have you draw it first on your own. But take a moment and have a shot at constructing that triangle, and then we'll chat about it and then solve it together too. So what's going on is that we've got these two folks standing at the beach, Jordan and Dana. They are 78 feet apart. Jordan's directly north of Dana. Jordan throws the ball into the ocean. It lands south 42 degrees east of Jordan and north 37 degrees west of Dana. Our question, our task, is to figure out the missing, our task is to figure out how far from each of these folks the ball lands. So we need to find side A and side B. What I'm labeling side A and side B. Pretty similar to the previous question, what we should do first is to figure out the missing angle measure in the triangle. We'll do it in purple. That's 180 minus the other two angles to get 101 degrees. And then we can set up the law of sines proportion to solve for A and B. So sine of 101 over 78 equals the sine of 37 over A. A similar type of proportion would work for B. It'll be the sine of 101 over 78 equals the sine of 42 over B. To solve for A, we'll cross multiply to get A sine 101 equals 78 sine 37. Dividing by sine 101, That tells us that A is equal to 78 sine 37 over sine 101. We get about 47.82, and the unit for this one is feet. So that, I'm at least content with the answer. Again, across from 37, we should have a smaller value than across from 101. 101 was 78, so whatever's across from 37 has to be smaller than that. Should it be half the size or less than half the size? I have no idea of that, but it should at least be smaller. And it is smaller, and it should be a fair bit smaller. And 47, subjectively is a fair bit smaller than 78. To get B, the exact same process will work. B sine 101 equals 78 sine 42. Dividing by sine 101, we get that B is equal to 78 sine 42 over sine 101. So the ball is 53.17 feet from Dana. That value should be bigger than A because the angle across from it is bigger than the angle across from A. So 47 versus 53, that at least seems reasonable. It's still fairly close, but there is a difference. But using the law of sines to solve these applications is exactly what you'll be doing for the week. My sincere recommendation for beginning that process is that you construct a diagram first, and that's the whole point of what we're talking about now. So I put another picture in the chat, another screenshot of another question. This is a later scenario of the question we just finished. So, the ball landed out in the ocean, and as things do over time, it just kind of drifted farther from where it originally landed. So what's happening now is that the ball is 48 feet directly east from where it landed originally, and we had this new angle relative to Dana. So what I'm going to do is give you a moment to take this new information and either construct a new diagram, or maybe you want to update this diagram. It's up to you. I'm going to draw a new one. So I'll give you a moment to incorporate this new information into a new diagram. So this current triangle is the collection of everything we were given originally and of the things we discovered from our earlier work. What I'm going to do now is update it with the information for this second part of the problem that says the ball is 48 feet directly east of where it landed originally. and it's now at a new angle relative to Dana. I'm gonna, guess I'll keep it in black. But this new angle is north 75 degrees east. So that means starting from the north, turn, oh my gosh, sorry. Starting from the north, turn towards the east by 75 degrees, and that's what we did. So this diagram now incorporates everything we're either told originally and figured out, or maybe what we were given for the second part. Our task is to figure out how far the ball is from Dana. I'll label that as side C. What we can do here, the first thing is we can label this, let's do it in pink. We can label the pink angle here. Any thoughts on how we can do that?
$75 minus that 37.
Right. These two angles together, the red, well, the 37 and then this pink one, they, in total, the two of them create the 75-degree angle. So 75 minus 37 tells us that pink angle is 38 degrees. We need to figure out side C. Remember, to use the law of sines, we need a couple things. We need a complete angle side pair, which we do have that, 38 and 48. That's a completed pair. We have the angle and the side directly across from it. But in order to find side C, we must know the angle across from it first, which we don't. So we don't know anything. We don't know side C. We don't know angle C. The only other piece of information we have in this question is the 53. What that means is that our next step has to be finding the angle across from 53. Let's see, I'll try to... Wish I had better colors. I don't. So I'll do it in yellow. I mean, that's showing up fine on my screen. If for some reason you can't see the yellow, let me know and I can do it in another color. But what we must do first is sine of 38 degrees. I'm going to label this as angle X. Over 48 equals the sine of X over 53.17. Cross multiplying here, we get 48 sine X equals 53.17 sine 38. Solving for X, we next need to divide both sides by 48. And then finally, we can use inverse sine to get that angle X is the inverse of 53.17 sine 38 degrees over 48. Again, using the calculator as few times as possible would be the best approach. So just a single time is what we'll do. We get 42.998, which actually I'm going to round to 43. So that missing angle in there, angle X is 43 degrees. That's what we now know. Now what we're after, that is not an answer to the question. The answer to the question is side C, which is how far the ball is from Dana at this point. The only reason we're finding the 43 is because that's what we could find next. We can't find side C, we can't find angle C, we can find angle X when I labeled as X, and so we did. But that helps us because now we can find this missing blue angle at the top by using 180 minus 38 minus 43. That top angle is 99 degrees. And now that we know that angle, we can solve for side C, once again by repeating the law of sines process. Sine 38 degrees over 48 equals sine 99 over C. But we could not find C until we knew the angle across from it, which meant we needed to find X first. Cross multiplying, we get C sine 38 equals 48 sine 99 and so C is equal to 48 sine 99 over sine 38. Single time, we'll put this in the calculator. 48 sine 99 divided by sine 38. Approximately 77.01 feet is how far the ball now is from Dana. I think that's who it is, Dana. Should be farther than it was originally. Originally, it was that 53 over there. It has absolutely drifted farther. So just again, kind of analyzing our answer in relation to other stuff we know. This doesn't guarantee that 77 is right, but our answer here absolutely has to be bigger than 53. So 51 would have been wrong from the, that's not going to happen. But 65, 77, 88, I don't know, have no way to compare any of those to each other. But it at least has to be bigger than 53, which it is. Questions about anything there? So this was actually a test question a couple years ago. So this, I'm just pointing it out because like literally this part and the part prior to it were part A and part B of a test question from several years ago. So this is a wonderful question to review, a wonderful one to retry. You'll have, of course, the recording and your notes and such. But this type of question is exactly the type of question you should be preparing to answer on a test. What I've just done, I put the second survey link in the chat, the same questions you answered at the beginning. Just now it's titled post-survey instead of pre-survey. If you would complete those two questions at some point before you leave, I would appreciate it very much. But what we'll do for the rest of our time is answer any questions you have. You have a test coming up this week, so I'm happy to do any test review questions or WebAssign questions or questions you have in your notes that you just are looking back at and need some refreshers on. But anything you want to talk about, we've got the rest of our time to do it. I have the chat open. I don't know why.
I just posted one in the chat.
Oh, yeah, I see it. Oh, okay. Yeah. This is a good question. Let's see, it's 11, I guess. So, what's happening here is we have a triangle inside of a circle. We know the angle in the middle is 110 degrees. The side across from it's 8.8. And we need to determine the diameter. How we're going to do that is by using the law of sines and the fact that both sides of the triangle are a radius of the circle. Right? If this angle is a central angle, meaning its vertex is at the center of the circle, the right side of the triangle is a radius, the left side of the triangle is a radius. What that helps us know, I'm going to go back to something I said a couple of times today, but larger angles create larger sides. Smaller angles create smaller sides. What if the sides are the same? What does that tell us about the angles across from them?
That they're probably the same.
That they're absolutely the same, yeah. So if this side is a radius and this side is a radius, that tells me that these two angles are identical to each other. They have to be identical if their sides are identical. So how we're going to find, I'm going to take most of that away, how we're going to find those two missing angles so that we can use the law of sines is by subtracting 110 from 180 to get 70 and then dividing it by 2 to get 35. Both of those angles are 35 degrees. So that now says we can use the law of sines by writing the sine of 110 over 8.8 equals the sine of 35 over r. R sine 110 equals 8.8 sine 35. And so r is equal to 8.8 sine 35 over sine 110. We need to round to the 10th. Okay. So putting it in the calculator, we get approximately 5.371408, blah, 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 which is a radius of the circle. The question, I believe, asks for the diameter. And the diameter, and so if we multiply that by 2, we get approximately 10.7. Okay, yeah, that's fine, Michael. No rush.
I had a question.
Okay.
Could we go over like a problem from every topic we're gonna have on the test, like inverse trig functions and so on?
I mean, I don't have those, and I don't have a collection of those with me. I mean, we can do any. If you want to find them, you can send them to me, and we'll do them. But I don't have a collection of every problem from every topic we've covered for the last few weeks. But I'm happy. I mean, we can answer it. I'll happily answer any questions you send over.
Yeah, I'll pull up some and then I'll ask.
Okay.
Okay.
Just I'm not. We probably don't have time to do one question from every single topic, though. So if there are certain topics that were more troublesome for you, my recommendation would be to start with those questions first. 30
Yeah,
minutes.
I had trouble with like rewriting and verifying problems.
Yeah, and so if you have any of those, send them over and we'll do them. Like I don't have any, so I mean I can't make up a verifying identity question just off,
Yeah.
It would not be a good idea for me to try that.
Yeah.
But
Okay.
we'll absolutely do them.
Okay.
I'm having trouble screenshotting 1B. Michael, I'm gonna open my lab manual. Unit 2 practice. Okay. One B. Page 34. Okay. Determine the angle of elevation. So just a general tip. Any angle you're asked to identify, like actually asked to provide the measure for, will have to be a 30, 60, 90, or 40, will have to come from a 30, 60, 90, or 45, 45, 90 triangle. Outside of that, you would need a calculator. And so just maybe again as a test taking tip, if the question ever says, what is this angle? If you don't have any idea, 30 degrees, 45 degrees, 60 degrees, those would be good numbers to guess anyway, not 28 degrees, because that's not one you could do without a calculator. So for 1B, we're told, let's see, John Daly hits a tee shot, it travels. So it starts here, it travels 165 yards horizontally when it reaches its peak. So the ball's somewhere up there at its peak. It's 100 when it reaches its peak. Express angle elevation. You're asking about B. Okay, so B doesn't have this number. I need to take that out. Sorry, I'm just trying to figure out what we need for B from the original question. We're asked to determine the angle of elevation if at some point the height of the ball is 495 divided by the square root of 3 feet. Okay. So thinking back, so I need to take peak out. So we're no longer at the peak. We're somewhere else. Thinking back to the 30, 60, 90, and 45, 45, 90 triangles. The 45, 45, 90 rule was x times the square root of 2. The 30, 60, 90 rule was x, 2x, and x times the square root of 3. And so what we've got here, we have a square root of 3, so that's a little bit of a tip that we're probably working with a 30, 60, 90 triangle and not a 45, 45, 90, because if it were 45, 45, 90, we'd have a square root of 2, which we don't. And so if we, just looking at this, if we apply the 30, 60, 90 rule, let's say the bottom side here is 495. If 495 is equal to x times the square root of 3, that would tell us that x is 495 over the square root of 3. That tells us that this angle, this actually is a 30, 60, 90 triangle. 30 degrees goes here. 60 degrees is at the top, but the angle of elevation we're after is 30 degrees. I haven't really done a whole lot of work. I did a whole lot of talking when I labeled some things, but the point of this question is to spot that this is the 30, 60, 90 rule for a triangle. And remember, for the 30, 60, 90, and 45, 45, 90 triangles, as long as you're given a single side length, you can find all the other information you need. And so that's another kind of giveaway or tip or hint for this one. Since you're only given a single side length, it's going to have to be one of the special triangles. this is kind of like the tree question from test 1, where you're planting a tree and you have a stake in the ground, something like that. I forget all of it now, but that was an application question using the 30, 60, 90 triangle, which is what this one is too. Just different numbers in a different context, but the same idea.
So are we going to have a recording?
Have what?
Can we get this as a recording in the chat?
Yeah, it'll be, the recording will be there.
Thank you.
Yeah. Could we do 3 from the same page? Yeah, so we'll, Hazani, Sarah, y'all, I'm gonna do I'm gonna do them in the order they came in the chat, but we'll do both of the 2 y'all put in there too. 3F on the same page. Okay, 3F. Well, it's not an example. 3F. 2 equals 4 cosine squared theta plus 1. So the first thing would be to isolate the trig function here, first by subtracting 1. And then dividing by 4. I'm going to flip it around as well. Cosine squared equals 1/4. To finish isolating the trig function, we should square root both sides, which tells us that cosine theta equals plus or minus 1/2. The square root of 1 is 1. The square root of 4 is 2. Questions up to here? Just in isolating the trig function, specifically for Michael, since it was your question. So far, so good. Okay. So what this is actually telling us is 2 things: that cosine theta equals 1/2 and that cosine theta equals negative 1/2. So we need all of the angles between 0 to 2 pi that have cosine ratios of 1/2. Those angles are pi over 3 and 5 pi over 3. We need all the angles around the circle to have cosine ratios of negative 1/2. Those are 2 pi over 3 and 4 pi over 3. Is that okay, Michael? Okay. Yeah, you're welcome. Hazani, yours is next. So one thing I'm going to point out, at least about your answer, just because I can see your answers in your screenshot, is that the question asked you to round to the nearest 10th, which means 1 decimal place, and at least your first answer was rounded to 2 decimal places. So that alone may be a reason it was counted as incorrect for that first one.
I completely missed that last part.
It's kind of normally WebAssigns normally it asks for 2 places, so that's probably, I mean, that'd be my guess about why you put 2, because that's normally what it wants. For some of these, it randomly switches over to 1 place. For some of them from a few weeks ago, it was asking for 4. Just, it's can be hard to keep it straight because it does sometimes vary, but okay. Let's see. Use the law of sines. Okay, so I need to draw something here. A is 19. Side A is 3, side B is 6. And we're asked to find the missing angle. Okay. So I'll go ahead and label that as B1, and I'll, if there's a second solution, we'll call it B2 when we get there. So we'll start with the law of sine. Sine of 19 degrees over 3 equals the sine of B1 over 6. 19 and 3, b1 and 6. Okay. Cross multiplying, we get 6 sine 19 equals 3 sine b1, which means that the sine of b1 equals 6 sine 19 over 3. And so b1 is the inverse of that. .63. Oh, I'm not rounding it to one place either, I guess. So 40.6 if we're rounding to two decimal place. Sorry, if we're rounding to one decimal place. And always, 100% of the time, if there's a second solution, it's going to be 180 minus the first solution, which in this case would be 139.4. Just another thing I'll point out with this question, it's asking specifically for the larger value versus the smaller value. So if that comes up or when that comes up again, don't put them in the order you find them. Put them in, like what Webb assigns after, smaller first in this case, and then larger. Azani, was that okay what we did? Okay.
I don't know how I got this one. I did it like 5 times, and I don't know what I did. I must have typed.
Are you in degree mode or in your calculator? That would be an easy way to do all the right work and still get it wrong.
You know what? I think I was in radians. I don't know if that would. I don't know.
So just anytime you see I'm pointing on my screen like you see it, but anytime you see the degree symbol with any of the angles, that means you'll need to be in degree mode. And with the law of sines and law of cosines, you will need to be in degree mode because the angles will be given in degrees for those. So now that we have the calculators, making sure you're in the correct mode, I mean, for test 3 forward, now that you will soon have those, making sure you're in the correct mode will be a really big priority, because if you're not in the correct mode, even if all of your work is right and you put it in the calculator in the wrong mode, it's going to give you back wrong answers. Okay, Sarah, yours is saying 2 sine pi over 6 cosine pi over 6. This expression, 2 sine pi over 6 to cosine pi over 6, matches the double angle rule for sine off of page 92. So off of page 92, we have an identity that says the sine of 2a is equal to 2 sine a cosine a. Our original expression exactly matches that. What I'm going to do I'm going to simplify it a little bit, not a whole lot, only one thing I'm going to do. But 2 times 2, we can rewrite that as 4. Actually, I'm going to do it down below. 2 times 2, we can write it as 4. And then to make this exactly match the 2 sine a cosine a that I've written in red, I'm going to rewrite it as 2 times 2 sine pi over 6 cosine pi over 6. But everything that I've got inside the red brackets, that is exactly the double angle rule for sine. What that means is I can take all of that out and instead write it as the sine of 2 times pi over 6. this 2 still comes into the front. But 2 times pi over 6, that's really pi over 3. But sine at pi over 3, we can evaluate that. Sine at pi over 3 is equal to the square root of 3 over 2. Still with the 2 in front, and so the 2's cancel and we get just the square root of 3.
Okay, sorry, I got kind of lost at the, like, when you got the 4.
Yeah. Here?
Yeah. So you multiplied the 2 with the 2 that's already in the formula?
No, I just multiplied both of these 2's together.
Oh.
So that I don't want them to be sprinkled around the equation. I just want all the numbers to be in front. So 2 times 2, that's 4. So I'm just multiplying them together to put the 4 in front is all.
So what about the 2 in the original of sine 2a? Like, doesn't that count?
What I've written here?
Yeah, that.
That's just no. So that's in red just to make it as a note. That's not part of our work for any reason. The work is what's in black.
Oh, okay.
We went from this top row to technically the second row. I only wrote what's in red so we could all be looking at the same identity at the same time.
Okay. We couldn't just go like sine of pi over 6 like on the unit circle and.
For this one, you actually could. So this question doesn't require that you use the identity at all. You can, I'll scoot it over a little bit, but like you absolutely could do what you're saying. Sine at pi over 6 is a half. Then there's another 2. Cosine at pi over 6 is the square root of 3 over 2. So yeah, 2 and 1/2 cancel. This 2 and this 2 cancel, and you still get the square root of 3.
Oh, okay. So I don't know how I got that.
Well, you have this. I went back to. I clicked on it. You have the square root of 3 in your answer.
Yeah.
You have some other stuff too. But
Because you said that in the form of a sine theta. I don't know what that meant.
Oh, I didn't even read that. So okay, so I'm going to take back what I said to you a second ago. You can't do what you're asking, but we shouldn't do what I'm asking either, because that's not what the question says. The question wants us to write it in the form of a number multiplied by sine of an angle. And so that's what we arrived at right here in blue. The question is actually asking you to rewrite it so that it does match the double angle rule for sine. It's not asking us to evaluate it. It's not asking us to get a number like what I got here or like what we got back here. It just wants us to rewrite it.
Oh, okay. Thank you.
Yeah.
I'm going to take a picture of this really quickly.
Yeah, let me... There you go. So...
Okay, thank you.
Yeah, you're welcome. Could we do 6 from page 34? But something. Let me find page 34 again. Oops. 34. But just what? Oh, Sonic. Oh, I see. Okay, yeah, sure. So from page 34, number 6, we need to find the exact value of the sine of x over 2. And we're told that secant of x equals 3/2, and the x is between 270 and 360, which means it's in quadrant 4. So anytime you're given information like that, the first thing to do is to create a triangle in the correct quadrant and label it correctly. So secant of x is 3 over 2. Another way to think of that, and maybe for me at least an easier way, is to think of it in terms of cosine. So if secant is 3 over 2, that means cosine is 2/3. So that means the adjacent side is 2 and the hypotenuse is 3. Using Pythagorean theorem, we get that the opposite side is negative square root of 5. 9 minus 3 squared minus 2 squared, and then take the square root of that. Is that okay for the triangle, Michael? Okay. So now I'm going to have to leave page 32 and go to page 92, or sorry, page 34 and go to page 92, because to find the sine of x over 2, we need to use the half angle rule for sine. That rule says that the sine of a over 2 is plus or minus, one or the other, 1 minus cosine a over 2. Sorry, I labeled this as theta. I didn't mean to do that. It needs to be an x, so I'm going to replace it with x. Oh gosh. Okay. So in our case, the sine of x over 2 is going to be plus or minus the square root of 1 minus cosine x over 2. Cosine of x is 2/3. I'm going to let's go ahead and talk about the plus or minus portion of this as well, the plus or minus portion in front. The angle we're looking at, the x angle, it's over here in quadrant 4. Think of any angle in quadrant 4. Pick any angle you want to be. 300 degrees, 310 degrees, 359 degrees. Literally doesn't make a difference. Pick any angle in quadrant 4 in degrees and divide it by 2. Which quadrant are you in now? The answer to that is quadrant 2. So angle x is in quadrant 4, but angle x over 2 is going to be in quadrant 2. Inside of quadrant 2, the sign values are positive, which means we need the plus version of this equation, of this identity. So we've applied the identity. The only thing left is to simplify it a little bit. Think of 1 as being 3 over 3. That will allow us to combine it 3 minus 2 over 3 over 2. That's the square root of 1 over 3 over 2, which is the square root of 1 over 6. Part A of 23 on 36. Part A. So 23 says that we have a population 500 sine 2t plus 2500. The maximum population will occur whenever the trig portion is at its maximum. The maximum sine can ever be is 1. So the maximum value for the population will be 500 times 1 plus 2500, which is 3000. Yeah, so it doesn't make a difference what. So just focusing in on the trig portion, right? I'm not looking at the 500. I'm not looking at the 2500. Just the trig portion part of it. Sine of anything can only ever be as big as 1. That is the maximum of the trig portion of this. So just substituting a 1 in its place is how we would find the maximum. So the 2t. Yeah, it doesn't matter. The inside is irrelevant. The maximum will still be the maximum. I mean, the maximum will still be 1. The 2t, the 2 in there only changes the period. The 2 is going to be a, so if we're talking about transformations, the 2 is going to be a horizontal change, but the maximum we're talking about up and down, we're talking about vertical. So the 2t, totally irrelevant to this question. Yeah. We have about a minute left. If maybe one last question. Somebody wants to toss one out here, we can do it. If not, of course, if you're ready to go, feel free to do that. No pressure to stay. But I'm up for, I have time for one more if you have one more you want to ask. 10 on 35. Sure. What? Which? Oh, 10E. Okay. I thought you were want me to do all of those. We don't have time for 5 of them. 10E. Yes. So 10E off of page 35. So similar to the one we did a minute ago, actually, the first step is going to be to draw triangles. So we're told that secant A is 3/2, and the A is in quadrant 4. We're told that sine B is 3/5, and B is in pi/2 to pi, so 2. So what I'm going to do is draw angle A in quadrant 4. Secant is 3/2. I'll draw angle B in quadrant 2. Sine is 3/5. To get the missing side for alpha, 9 minus 2 is the square root of 5. It should be negative though, since we're in quadrant 4. For B, the missing side is going to be 5 squared minus 9. That's a negative 4. The square root of 16. And so we need for E, cosine of alpha minus beta. I need my sheet. Cosine of alpha minus beta, that's the sum and difference rules from the top portion of the page. Cosine of alpha minus beta is cosine alpha, cosine beta, plus sine alpha, sine beta. So cosine from triangle A is 2/3. Cosine from B is negative 4/5. Sine from A is negative square root 5/3, and then sine from B is 3/5. That gives us negative 8/15 minus 3 times the square root of 5/15. Since the denominators match, we can combine those to get negative 8 minus 3 times the square root of 5 over 15. Whoops. Questions there? Yeah, the negatives are really important. I assume you're talking about maybe these ones. I don't know. I guess you could be talking about them down here too. But yeah, for sure. Not a major deal in the schema. I mean, there's a whole lot going on here. You know, the negative signs are really minor detail in that process, but it's just as essential as, you know, everything else, of course. All right, so it's 4:33, which is when we end. I'm just making sure that's true. Yeah, 3 to 4:30. So I'm going to stop the recording